things you should know before tackling on this lesson. A plane is a flat surface such that if any 2 points are on a surface are connected by a line, all the points on that line are also on that surface. There's a few postulates about planes. 3 non-collinear points determine the plane. If you have a plane and the line intersecting it that is not in the plane, then they intersect at exactly 1 point. Plane intersected by another plane the point of intersection is exactly 1 line. Now it's time for some theorems. A line and a point that is not on the line determine a plane. 2 intersecting lines determine a plane as well. 2 parallel lines, which means they never intersect, determine a plane as well.
Here's a tip about solving 3D proofs. Basically, if you just take your rules that you know from your previous proof lessons, you can take those and apply them to the 3D figures, and therefore allowing you to solve them just like any other basic proof.
Here's a practice proof. In the diagram, you have plane, G, and 2 triangles. You're given that ND is perpendicular to AD. You're also given that ND is perpendicular to DI. In addition to, AD is congruent to DI. You have to prove that NA is congruent to NI. If your proof looks like this, you're correct. We chose to solve it this way because the easiest way to prove congruent segments is through congruent triangles. And since we were already given congruent segments in the given, we simply use the information given to prove congruent angles and one more congruent side through a reflexive property, which gave us a congruent segments through CPCTC.
Hi, today we're going to be teaching you about parallel planes. Do you know what a plane is?
Not that kind of plane. 2 planes are parallel if they do not intersect. 2 lines are skew if they're not coplanar. But, however, there are no skew planes. They either intersect or are parallel. Here's something you shouldn't assume.
So although these lines may look parallel, for example, C, B, and WX, they are actually not parallel because the lines are skew, meaning they're not on the same plane. And lines can only be parallel if they're on the same plane. Here is some parallelism of lines and planes.
If 2 planes are perpendicular to the same line, then they're parallel.
If a line is perpendicular to one of 2 parallel planes, then it is perpendicular to the other plane as well.
If 2 planes are parallel to the same plane, then they're parallel.
If 2 lines are perpendicular to the same plane, then they are parallel.
If a plane is perpendicular to one of 2 parallel lines, then it's perpendicular to the other line as well.
If a plane intersects 2 parallel planes, then the lines of intersection are parallel.
What are the lines of intersections, you might ask? Right here and here. They're parallel.
And now, onto a real-world problem. Okay, so in this problem, we're going to be pretending to build a ladder shelf. If you don't know what that looks like, I'm going to insert a picture right here. I drew what would be a side view of the ladder shelf. So this would be the wall, and this would be the floor, which means this is a 90-degree angle, which we're going to need to use later. This is the leg of the ladder, and these 3 are the shelves. So what we know about this already is that these are parallel planes. So these 3 are parallel, and they're also parallel to the ground. What we're going to need to be doing is to solve for the smallest length that this can be in order for it to touch both the wall and the leg when the ladder is out 27 inches. So the first thing we need to do is solve for this angle, and to do this we're going to be using the tangent property. So what we need to do is use its opposite over its adjacent. So we're going to put in second tan 36 divided by 27, close parentheses, and we get 53.13 when we round it to our nearest hundred. So now we need to figure out what the rest of these angles are. In order to do that, we're going to go back to a property that we learned earlier about parallel lines that we can apply to parallel planes. And this is corresponding angles. So what we know from corresponding angles is that if two parallel lines are cut by a transversal, then this angle and this angle are congruent. Now, we have this right here, as you can see, with this angle, this angle, this angle, and this angle. These four are all corresponding angles, which means they're all congruent. This means that this top angle right here is also 53.13 degrees. Now, we're going to need to use the tangent property again to find out the minimum length that this shelf needs to be. So what we're going to do is we're going to plug in tangent of 53.13, which equals 1.33 when you round it to the nearest hundredth, and then you're going to take 7 and you're going to divide that by 1.33, and the length of the shelf is 5.26 inches when you round it to the nearest hundredth.
If a plane is perpendicular to two parallel lines, oh wait, frick. Okay. Dara, you messed up too, remember? If a plane is perpendicular, sorry. 1, 2, 3.
WX.
When solving 3D proofs, you just have to take the oops.